Good morning. Going to hit seeds and seedlings today. We went through kind of how the seeds are formed, how the embryo gets formed through the sporogenesis. So now what we're going to do is kind of go even more in depth as to how those seeds then germinate. So a couple of quick things. Two major groups that reproduce by seeds are going to be the angiosperms through their flowers, and then the gymnosperms through their cones. So they're going to have the seeds embedded within their cones. So two major plant groups that produce and reproduce by seeds would be these guys. This is kind of a review from Monday, but with your seeds, this is the reproductive structure that's formed after fertilization occurs. So it's a diploid organism, the 2N organism. It's going to contain the three major things so all seeds will contain these three things: a testa, an embryo, and stored food. Remember, the testa is that outer covering, that hard outer shell kind of going around the seed, and then the embryo itself. And then the stored food is either going to be a cotyledon or an endosperm. So the interesting thing to note about the dicots and monocots with the endosperm is at maturity, the dicots don't have an endosperm, but at maturity, monocots will have an endosperm. So interesting little fact there. Angiosperms, kind of a refresher, you can be either a monocot or a dicot. You're not going to get a monocot and a dicot when you're talking about a gymnosperm. So, and then again, the monocots have one cotyledon, and the dicots will have two cotyledons. So we'll kind of go over this and then we'll talk about the diagram here. Your dicot seeds are going to have two cotyledons. They're going to have a shoot and a root apical meristem. They're also going to have an epicotyl and a hypocotyl. And then the testa, which would go around it. So, and then eventually you're going to get that stored food as the cotyledon or the endosperm, usually the cotyledon. So if you look at your diagrams that I've drawn for you, this one is already technically germinated. So that embryo is kind of there in the center, kind of that middle part. From that is going to form the two cotyledons. Up above the cotyledons is going to be the epicotyl. So your epicotyl is always going to be up above your cotyledons. The very top of your epicotyl is where the shoot apical meristem is, and that is going to produce those baby leaves or foliage leaves. Below your cotyledons will be the hypocotyl portion that eventually tapers off into the radicle where your root apical meristem will be located. So that's kind of your diagram there. I have down that the plumule, or sometimes what those initial baby leaves are called, plumule. But okay, moving on. The epicotyl and the hypocotyl will be important here when we talk about how the seeds pop through the soil. So it may not make a lot of sense right now, but it will. Your monocot seeds. I drew a corn kernel. It's a very well-known monocot. So like the name implies, there's only going to be one cotyledon. You're going to have, just like with your dicot seed, you're going to have a root and a shoot apical meristem. You're still going to have an epicotyl. I misspelled this next part. You're going to have a coleoptile. So there technically should be an O here. Sorry about that. So coleoptile. You're also going to have a coleorhiza, and then you're going to have the stored food as your endosperm, in the form of your endosperm, I guess I should say. So if you look back at your drawings, the vast part of this particular seed is the endosperm. All that stored food there. Then off to the side, you've got your cotyledon there. There's only one. So you've got your one cotyledon. You can kind of see the beginnings of the root and the shoot there. It sprouts straight up and down rather than through the cotyledon, I guess I should say, as opposed to the cotyledons coming out from the sides. So with this, we'll go with the top part. The top portion of that is going to be the coleoptile. Then you're going to have a bottom part, which is going to be the coleorhiza. So at the top of the coleoptile is going to be your shoot apical meristem. The bottom of your coleorhiza is going to be the the root apical meristem. And then kind of just like with the dicots, you are going to have the epicotyl up top, and you'll have the radicle down below. The hypocotyl oftentimes is denoted by the very top part of that coleorhiza. Sometimes that's what it's denoted as. So, and then your cotyledon there is that whole kind of side structure that your coleoptile and coleorhiza kind of make up. So that's your basic structure of a monocot seed. So okay. In order for seeds to start growing and to germinate, they need three things. They need water. Obviously, that's the most important thing that starts to trigger those chemical reactions that allow for cell growth. They need oxygen. And then they're going to need a proper temperature. Sometimes that's going to be, I don't want to call it a shock, but sometimes it's putting it through a different type of temperature. Sometimes you have to store it at a cold temperature in order for it to germinate. So, but you, I'm sure, are probably familiar with that. So sometimes it's a warmer environment and they germinate better. Sometimes it's a cooler environment. So, but it is dependent on temperature. So, okay. Next thing. There's a couple of things that sometimes have to occur to get the seeds to germinate. Some special, I don't want to call them steps, but they're kind of our steps that your seeds have to go through in order to start germinating. One of which is dormancy. So sometimes the seed has to go through that period of rest, and I don't call it sleep, but to where it's just inactive, I guess would be a better word. And oftentimes that occurs in cold temperatures. So oftentimes this occurs in cold temperatures. And the cold temperatures just, they just need that time to process and go dormant, generally something's got to happen to get it out of dormancy. So, which we'll get into here in a second with the stratification. So, scarification, my guess is you might be familiar with this as well. Sometimes the testa has to be broken down a little bit more because it's super, super thick or super tough for whatever reason. And so it needs additional cracking or wearing down in order to allow those cotyledons to emerge and the foliage to be produced and to encourage that seed to just start growing. So that and nutrients can't get into the embryo. So yes, it's got some with the endosperm, but it obviously needs the oxygen and the water to get through that testa so it can start developing. So sometimes you can do that chemically. We'll talk about that, I think, on the next slide, like a quote-unquote chemical scarification. But no, that's stratification, sorry. So with the scarification, one of the more well-known things is sometimes birds will ingest certain seeds, and the seeds are dependent on that. They need the birds to ingest them, so that way the enzymes in the birds' stomachs will break down that testa. So then the natural environment can then encourage the germination. So then it wears it down enough to where oxygen and water can get into the seed so it can start that germination. So that would be scarifying, breaking down that testa, that tough testa. Okay. Stratification. This is the process of treating your seeds to encourage germination. This is the one that I was talking about earlier that I mixed up. Sometimes you can do something physically to the seed. Sometimes you have to expose it to a chemical. Factors to encourage it to germinate. So generally, this one kind of helps wake the seeds up out of dormancy. So one thing, so sometimes it's trying to simulate some of the things that would happen in nature. So sometimes you're told to put your seeds in cold storage for a couple of days or a week or something. That's exposing it to it's trying to mimic an external environment situation to where like in the winter when the seeds would be going dormant in the cold soil, in the cold ground. So you're trying to mimic that. So after ripening is another way method of encouraging seed germination. With this one, you're allowing seeds, they've been harvested, so now you basically just kind of let them rest to encourage that germination. So these all kind of can all sometimes kind of just go together, that a seed might go through several of these, I don't really call them steps, but yeah, the word's escaping me. So they kind of go through these different stages maybe. Oftentimes with after ripening, it's done in a cool, dry storage situation where they're just allowed to rest. Um, then they'll be planted and exposed to the elements so that way they can germinate. So they ripen after they've been harvested. So I think that's where that terminology comes from. The last way is through chemical treatment. This one's not uncommon at all. And this one is that, like I was saying, the chemical scarification, the breaking down of that seed coat through chemical means. So sometimes you have to put your seed into either a water soluble situation, or sometimes you have to put them into a chemical, the vice versa. And so, for instance, what I've got there to encourage the germination. And so what I've got here is that sometimes in the testa, they've got a chemical inhibitor that's protecting the seeds, that's saying almost like another protected layer that will prevent the seed from germinating. However, these chemical inhibitors are generally water soluble, so in an early spring shower, they will those chemicals will be washed off, and then when those are washed off, you're able to penetrate through that testa, the water and oxygen are able to break through that testa and then are able to reach that embryo and start the growth. Sometimes you have to put it into a chemical to wear down the seed testa. So if you flip to the second page that I've given you, it's not the drawings that I've given you, it's just the second page. I have kind of a table there of some conditions required for seed germination for some plants. Your citrus family doesn't really require any additional help. You just could literally take one of those seeds and plant it and grow yourself the plants for the orange plants or the lime plants or something. So the honey locust needs to be scarified by putting it into that concentrated sulfuric acid for an extended period of time. Excuse me. Your next group, the third one, the oak trees and the peach trees and the cherry trees, they need to be put into cold treatment for a very extended long period of time for the stratification part. So they're mimicking that stratification or the dormancy there. And then number 4, the basswood is another. It's a combination of the scarification and stratification. So you can kind of see those. Just some. Obviously, there's more than just those. So last one is your last set of drawings. Just how they germinate. They can either form a hypocotyl hook, an epicotyl hook, or a coleoptile hook. And your drawings kind of show you those. Your bean plants are your typical hypocotyl hook plants. So you start with your little bean seed, and it starts to germinate, and it makes that top part. If you flip back to that dicot, you can see that you've got definitely a top and a bottom. Now that you're going to have a cotyledon, you're going to have the cotyledons popping out here momentarily, but you've got your radicle starting to grow down, your hypocotyl growing up. Eventually, they kind of bust out as one, and your hypocotyl then starts to hook upward, and then your radicle and your root apical meristem are down below. And then eventually that hypocotyl hook pops up a little bit, because that's one of the first things to emerge from the soil. That's why it's called the hypocotyl hook. And then it wears down. It's not still that shell, but eventually that shell, that testa opens, and you'll see the emergence of your cotyledons, which kind of look like leaves. And then up above, you'll get those baby leaves or the foliage leaves. Foliage leaves coming up on the top. So then the space between, and if you go back to the front of that dicot, you can kind of see that you got your baby leaves up at the top, and then your epicotyl, and then your cotyledon. If you look here, you've got your baby leaves or your foliage leaves, then you've got your epicotyl and your cotyledon, and then your roots below. So in this case, the cotyledon is above ground. So you can kind of see that whole structure there. But so that's your hypocotyl hook. Your epicotyl hook tends to be with peas. So you've got your little pea there, and then it's got the growth of the radical comes out. And then you eventually get your epicotyl growing upwards. The hypocotyl is technically underground because the seed itself, that structure below the ground, that becomes your cotyledon, but it stays below ground. And since your hypocotyl is inferior or below your cotyledon, that's going to be below ground instead of above ground, like your bean plants. So your epicotyl then is the first thing that emerges up on the top when you start germinating. And then your foliage leaves pop up, and really all you see is the foliage leaves and your epicotyl. Don't really see your hypocotyl and your cotyledon. Those would be below ground with your epicotyl hook. So your last one is the coleoptile hook. So corn, so another monocot here. Since obviously they don't, your dicots don't have a coleoptile. So you've got your corn, you get your coleoptile popping up on the top, which is that top part. If you flip back to your monocot diagram, you can see that the coleoptile is the top part with your shoot apical meristem, and your coleorhiza would be the bottom part. So you got your coleoptile shooting up at the top, your radical down below. Eventually, that coleoptile is just gonna shoot straight up. Think of like the blade of grass, or like the example is corn. I guess I always think of grass. I guess when I think of monocots, but corn is just gonna shoot straight up, and that's gonna be that coleoptile portion there, and so that's going to emerge above the ground. Your radical goes below the ground. You end up getting some foliage leaves up at the top. So, and then your radical will be down below. So that whole upper part is, the upper part plus some of the part underground is going to make up your epicotyl. The cotyledon itself kind of falls away as this one's developing. So, and then obviously they just grow taller and create more foliage leaves. So they don't really. It's not the same as an epicotyl hook. Primary reason is you don't end up with the cotyledon there towards the end. So. And technically, you can have an epicotyl hook with a dicot. You can't have a coleoptile hook with a dicot. So, please let me know if this doesn't make sense. Your quiz tomorrow will be over meiosis and all of that sporogenesis. I won't stick this stuff on your quiz, so you don't have to worry about that being on for tomorrow. And then tomorrow we'll start seeds, or sorry, it's not seeds, your fruits, which is, I think, fun. So a little bit easier, I think. So, but a lot of parts because you break apart the different fruits. But I think pretty interesting. So again, if you do have questions, just let me know. Otherwise, have a good day.